Alright, this is a long video, so I cut it into two. And so we're going to use complex numbers to write this and this in simplest surd form. So if you remember what surds are, they're things under square roots that can't be simplified any further. Okay, so like non-perfect squares. Okay, so what we're going to do is we're going to treat this like it's a complex number. So we're going to add that into it. And when we do that, then we know that we have this. And what we want to do is we want to break this up into two things being added together. So we're going to write it like that. 3 plus 4 is 7, and this is going to simplify to pi fourths and pi thirds. And those are two things on our unit circle that we know where they're at. Okay, now if we write this in, we know that this is going to be multiplied together. So we're just using those properties of cis. Okay, and then from here, if we write them out, we get cosine of pi fourths plus I sine of pi fourths multiplied by cosine, whoops, this is supposed to be pi thirds, cosine pi thirds plus I sine of pi thirds. Okay, keep going. Now, when we do this, we're going to actually multiply these out. Or no, actually, let's simplify them first. So, unit circle. So if we have our 3 tick marks, this is pi thirds, and that's going to be 1/2 square root of 3 halves. And then this one is pi fourths, and that's square root of 2 over 2, square root of 2 over 2. And that's all we need for this part. So cosine is going to be the x value, so we get square root of 2 over 2. And then this will be the y value, which is also square root of 2 over 2. And then right here, we get the x value, which is 1/2, and then square root of 3 over 2. Okay. Now, what we want to do from here, we want to multiply this out. So I'm going to do this times this, which is going to be square root of 2 over 4. And then this times this is going to be square root of 6i over 4. And if we do this times this, we get square root of 2i over 4. If we do this times this, we get square root of 6 over 4i squared. Alright, so we just need to combine those. Remember that I squared is -1, so we're just going to change the sign right there and get rid of the I squared. Okay, so this and this are the real part. So we have square root of 2 minus square root of 6, and those are both over 4. And that's our real part. And then we're going to have our imaginary part, which is square root of 2 plus square root of 6 over 4. Okay. Now, what we're going to do, we're going to take this and set it equal to the real part. So we're going to take this thing. So let me just rewrite this. So it's cosine of 7 pi twelfths plus I sine of 7 pi 12ths. Okay. So we're going to set the real parts equal to each other. So cosine of 7 pi 12ths is equal to, now these could combine and be just over 4. So square root of 2 minus square root of 6 over 4. And then same thing over here, sine of 7 pi 12ths is equal to square root of 2 over 4 plus square root of 6. And that's all over 4. And that is it. All right. Now, let me just get back to the beginning. Okay. Now they give us a complex number that looks like this. And they're telling us that this is obtuse. Find the modulus and argument. Okay, so we have 2z is where we're going to start. And so we know that 2z is just going to be this thing multiplied by 2. So it's going to be like that. And so if we find the modulus, it's just going to be the piece out in front. And the argument is going to be unchanged from the original. So the argument of 2z is just theta. Okay, same situation. This time they want us to find z over I. And if we remember that I is equal to cis of pi halves, that's something we've been using on previous problems. We know that z over I is going to be equal to z over I. Okay. Now, if we use our division properties of cis, then we know that z over I is going to be equal to square root of 2 cis and subtraction. And that means the modulus is still going to be square root of 2, and then the argument of z over I is going to be equal to this. Okay? All right, now let me get some more room. We have one more part to this one. They want us to find 1 minus I times z. So first we need to figure out what 1 minus I is. And so if we draw a picture, we're going to go 1, negative I. We get this right here. Since this is the same as this, it's a 45, 45, 90 degree triangle. And so we know that the rotation here is going to be negative pi fourths. So that's the same as 45 degrees. And we know where it's at. We know that it's in the fourth quadrant. So we know it's right there. Okay. So if we do that, then we know that's square root of 2 cis negative 4. Okay. As far as finding the modulus from here, this is 1, this is 1. So 1 squared plus 1 squared equals, I guess, length. let's do capital L squared. So that's going to be 1 plus 1 equals L squared. 2 equals L squared, square root, so the square root of 2 equals L. Okay, that's how I got this. Okay, now that we know that, we're just going to multiply this by this. So we get square root of 2 and then square root of 2. Okay, and if we multiply these together, square root of 2 times square root of 2 is just 2. And then when we multiply this, we just add them together. So theta minus pi fourths, and that's going to be our final form. And so to get the modulus of this, it's just going to be 2. And then the argument of 1 minus I z is going to be equal to theta minus pi fourths.